Hello everyone. Today we are here to discuss light, and our objective for today is to be able to identify the properties of light. So first of all, c, lowercase c, is the speed of light. It is 3 times 10 to the 8th meters per second. It is on the reference table. Light can only move at one speed in a vacuum. It can't slow down or speed up if it's in a vacuum. And there is a wave equation that we've talked about before, and it applies for light as well. But in that equation, you can replace v for c. Since the velocity is always c for light. Okay, so this is the reference table chart for the electromagnetic spectrum. The light that we see is here. So here is the visible. It's only right here. And if you notice, this is in wavelength in a vacuum in meters, whereas this here is the frequency in hertz. And notice that this is times 10 to the negative 9th, 10 to the 4th, and this is 10 to the 21st, and to the right it goes to 10 to the 5th. Okay, the longer waves are radio waves. So this is long this way. Short waves are over here. So this is like 1 meter right here. This is times 10 to the 4th meters, and this is times 10 to the negative 13th meters. So gamma rays are the shortest, and radio waves are the longest. We also talk about AM radio waves. FM radio waves are shorter than AM. Then we have infrared light, also microwaves, which are a little bit longer than infrared. Ultraviolet, X-rays, and gamma rays, they overlap with one another. So down here, this is this is going to be times 10 to the 14th. This is hertz. This is frequency. Because you see that it fits into the 15th and the 14th right here. Fits right in here. So the wavelength isn't listed. For the visible spectrum. I mean, it's times 10 to the negative 6th, just about, but to find the wavelength, you can use the wave equation, and that's going to be V, it's going to be V equals F lambda, but remember this right here is c because it's the speed of light, so it's c equals f lambda, and then you can solve for lambda. So it would be c over f is equal to the wavelength. Okay. This is the visible spectrum. The white light splits into colors of the rainbow when it's passed through a prism. And it goes in order: red, orange, yellow, green, blue, indigo, and violet. So we like to say that there's more to the spectrum than what you can see. So it's more than just the visible spectrum. This is the electromagnetic spectrum, and that's all light. It's all different types of light. And then we also have the Doppler shift for light. If a light source, a star, is approaching, its light will be shifted to the blue end, so there's a higher frequency. If it moves away, there will be a red shift.